In this series of videos and study notes entitled Chaos to Order, I'm seeking to show, talk about, and hopefully help instill in people what I believe to be the most essential ingredients for successfully doing mathematics at any level. In some sense, it doesn't matter whether we're talking about pre-kindergarten to advanced doctoral studies or anything in between. While the content will naturally vary, the approach, the mindset to doing mathematics effectively is by and large the same throughout. The subtitle that we have here, Math by Research, is intentionally ambiguous in that what we're going to be looking at overlaps everything from learning math to solving math problems to applying mathematics to real life to anything that might rightfully be called doing math or thinking mathematically in whatever way, shape, or form that may take, because there's a lot of overlap between those different endeavors. Amidst these different activities of whether it's the doing, the thinking, the solving, the applying of mathematical principles, the common thread to doing it well is going to be that our most important tool at our disposal, the most important quality we can bring to bear, is the mind of the incessant researcher who never stops craving the resolution to the nagging how and why questions. What is the reason for this? How does it work? Why is it the way that it is and not something else? These are the type of questions that are, in fact, the most common characteristic and trait in common between the kindergartner and the professional scientist, both of whom never stop asking the question, why? Why is this so? Why this and not that? They're both consummate researchers who are never satisfied with simply observing or being told something is the way that it is. The kindergartner and the professional scientist both want to know, well, why is it the way that it is? Couldn't it be some other way? What's actually going on here? What's going on behind the scenes? What are the underlying principles, whether they ask the question in that way or not, what are the underlying principles that are driving the thing that I'm seeing on the surface? What's going on behind the scenes? If we can avoid quenching and suppressing and repressing and squishing the innate kindergarten researcher and kindergarten scientist in all of us, because we have within us, in our created being, that the desire for asking these questions, for researching and understanding the world around us. 3, 4, 5, 6-year-old children are some of the best researchers out there, because in our being we were made to not simply make it by in this world, but to take dominion of the world around us, which requires not simply memorizing laws and rules and principles and facts, but understanding what's actually going on all around us. What is it all about? If we can avoid quenching that kindergarten researcher and kindergarten scientist that we have in us, and instead foster and develop and cultivate that inquisitive nature, then we will have the skills necessary to effectively do math in all of its manifestations, and for that matter, any scientific endeavor in its manifestations, and for that matter, going further, anything in life that involves critical, analytical thinking, logic, rationality, which hopefully means everything, right? We want to be rational about everything that we do, I hope. So that's what we're going about in this series here. Our quest is to cultivate the explorative and inquisitive, searching mind, the research mind, that in particular within the realm of how it shows forth in mathematics. So hopefully to develop those skills that enable us to do math well, and that then carry over to other areas of being clear, rational thinkers in general.